Hi everyone, I am Fong Yiqian. Today I will focus on the presentation on the 3D solid modeling phase of the Pintu, Gerbang, Kota, Sultan, Ismail, Petra, which was performed entirely within the Tinkercad platform. The primary goal of this phase was to translate the raw dimension from the 2D engineering drawings into a realistic, colored, and structurally sound 3D digital mock-up that is ready for physical 3D printing application. So to start the entire design process, the very first step involved calibrating the workspace environment. In this setting, I set the base of the workspace into 300 × 300 to make sure that the entire building can fit into the space. And the snap grid was initially kept at the default 1 mm to quickly establish the massive foundation block and the basic structural footprints. This precise workspace calibration was crucial to ensure that every individual pillar, roof component, and panel would align perfectly along the central axis without any overlapping, mesh error, or loose gap. Once the workspace was calibrated, construction began on the primary load-bearing elements, the vertical pillars. The monument features a highly symmetric stepping layout. To achieve this, a single base pillar was modeled first using a solid rectangular box, which is the base on here. A specific height rule was implemented. Each flanking pillar was designed with a strict height increase of exactly 4 mm as the layout moved toward the center. The difference of height of each pillar is 4 mm. This 4 mm progression created a perfect calculated slope that naturally draws the eye toward the center of the monument. The most challenging part of the pillar construction was adding the signature recessed yellow panel, which is here. Because this panel sits sunken into the concrete in real life, a Boolean hole strategy was used. A secondary solid box was created, sized down to the panel dimension. This hole tool was pushed exactly 0.5 mm into the face of the main brown pillar to cut a precise cavity. Because the Tinkercad defaults to 1 mm snapping movement, so it's quite hard to move the yellow panel into just 0.5 mm. Because if I move in 1 mm, it will be too deep. So this is quite a challenge when I have to insert every yellow panel with exactly 0.5 mm. So this allows for micro adjustment, preventing the yellow panel from sinking too deep or sticking out to ensure a clean, uniform depth across all column faces. Moving upward, this component required a lot of geometric detail because they consist of multiple layers stacked together. To build a single dome, individual basic shapes, specifically a paraboloid, sphere, and cone, were pulled onto the workplane. To assemble them cleanly, the align tool was heavily utilized to make sure that every single layer stacked perfectly at the center. On top of the highest central pillar, which is here, the open book emblem was constructed to represent the book. This required importing a book-like shape, which I used the shape roof. Since the rack has a distinct asymmetry profile, the rotation wheels were adjusted by small degree to make sure it looked accurate and structure balanced from all viewing angles. Two boards was located asymmetrically to form this crossover book rack. And also for the upper part of the pillar, I create the shape for the dome so that it's easier for me every time to pull out this shape. When I build the shape, I actually use a large size so that it's easier for me to focus on every detail, and when I want to put it onto the pillar, I resize it to the perfect scale. Each layer of this dome was built accurately according to the actual structure of the building. The next major component was the grand traditional roof structure that spans over the dual traffic pillars. Since the Tinkercad does not feature a single pre-made shape that complex slightly slanted profile here, so the entire structure has to be created from the scratch by combining different blocks. For this roof, I use three shapes actually, which is a roof shape, a rectangular shape at the base, and a triangle shape at the slanted part. And to create the slanted from the roof to the bottom, I use another of roof shape to create that slanted features. Custom wedge and roof shape were selected, rotated, and trimmed at the precise angle. This careful placement eliminated any accidental hanging gaps and ensured the roof looked completely integrated with the pillars below. As you can see, it's connected perfectly to the both pillar besides and also the panel below. The final phase of the modeling process focused on workflow optimization, part management, and preparing the file for the final output. Because the monument is highly symmetrical, so it would be inefficient to build all 13 pillars and their complex domes individually from scratch. So instead, I use a smart grouping and bundling and also create my own creation shape techniques to ease the process. So once a single column was completely finished, I also saved the pillar's shape at my own creation part so that it's easier for me to pull out every time I need the shape. All of those individual shapes were highlighted together and merged using the group tool. So as you can see, since I already finished all the build process, so all structure actually will lock to make sure that it will not move easily or accidentally move. So if I unlock one of it, the shape was grouped and bundled. So that's all about my building process of the Tinkercad 3D modeling. In conclusion, by mastering shape manipulation, utilizing precise grid configuration, and use of the smart grouping strategy, the digital mock-up successfully captured both the engineering skill and the cultural beauty of the monument. That's all from me. Thank you.